Hi, everyone, and welcome to today's live stream. We have a very special guest today, Abby from Google, who is going to walk us through building AI agents with Gemini. Hi, Abby. It's great to have you here today.
Hi, Mira. Thank you. Hi, everyone. It's great to see you all here. I'm
Perfect.
Abirami Sukumaran, developer advocate at Google. And sorry, Mira, you were saying something?
No worries. So, yeah, everyone, while we're waiting for more folks to join in, can you share where you're joining from? We're streaming this both on LinkedIn and YouTube, so you can use the chat function to just, tell us where you're joining from. Meanwhile, my name is Stanimira Vueva, or Mira for short. I'm a developer advocate at MongoDB, and I'm joining from Sofia, Bulgaria. So it's great to have you all here today. Do I see any of the comments? I see some of them. Yeah, awesome. So many people joining from many destinations this evening. It's like super late for you, Abby. What time is it in Bangalore?
It's 10:30.
Oh yeah, that's dedication. And sorry for keeping you up for so late.
No worries. It's always interesting to talk with you and also about the intersection or the integration of MongoDB and Google Cloud and such interesting use cases we have. So it's nice to talk about it.
That's awesome. Yeah, so today, as I mentioned, we're going to talk about building AI agents. We're also going to discuss multimodal tagging and analysis of images. Also, we'll talk a little bit about sentiment analysis, how you can do that with Google Cloud Gemini. We'll, of course, pull in MongoDB Atlas into the picture. And then Abby will take it from there and talk to us about an exciting, really new topic, which is building AI agents. Abby, what happened in Google? Why is this such a popular topic right now? I have seen like many articles and many people talking about agents in the past 2 months. So can you get us up to date a little bit? What happened there?
Absolutely. So the main driving factor, in my opinion, is the fact that we, on top of being able to getting generative insights, being able to get generative insights from large language models, now we are able to plug that in the results from your large language models or insights, which we'll see in a little bit in our demo. We are able to plug that in directly to Agent Builder, which allows us to build these conversational bots, or what we call as the conversational assistants, with very minimal configuration and basically very minimal coding and only with configuration. And also, you will have to do some amount of coding for setting up the data and everything that in your backend, if that is how you typically do it, or if you have it in any other format as well, whether you have it as a CSV or have it as a PDF in your data store. You can plug it in, whatever the source may be, or just directly from BigQuery or MongoDB, any endpoint for that matter, and then directly plug it in and get your agent set up and have a real life conversational bot deliver. And not just that, you have API endpoints to the conversational bot, which you can then plug into your front end. So that is actually why it's why everybody is going crazy about it. At least in my opinion, I find it very intriguing to be able to get that set up for all the use cases that we've been talking about in the past. Like, we have done this bookshelf app together. We've done, I think the last time we did was some employee use case, bookshelf use case together. Now we do it. We are doing this restaurant review use case. So if you think about it, all the insights that we get, if we are able to get the results to queries in a question answer fashion or in a chat fashion, there's nothing like it. And that's what the agent builder enables or empowers developers to do. And that too with very minimal coding. And that's probably the reason why it's everybody's talking about it, at least from a development
It's really
perspective.
cool, yeah, but like the target audience is still developers, right? It is kind of a no code or low code solution, but you still need to have some technical knowledge to take advantage of that, if I'm understanding the whole agents concept correctly.
Correct. It doesn't require you to do extensive, or require you to have extensive programming skills, or you don't have to have come from a programming background to use that. But there are a lot of things. which you can leverage and take advantage of if you already are from a programming background. So that is definitely going to help. But nevertheless, it is still set up in a way that for your the simplest of the conversational experience can be obtained without much of coding or anything of that sort. Even from a data perspective, if your chatbot is very interactive, you just want the bot to answer very generic questions, you could just plug the agent builder in with a generative AI model of your choice and just leave it at that without customizing it with any of the data sets for that matter. Unless you have very specific data and very specific use case where you have a designed set of steps or designated endpoints which will return the similarity searches and other things, you could just plug it in with generative AI models, one of the generative AI models, and directly get a very simple conversational experience. So yes, it's actually yes and no. If you have programming background, definitely it will help you take advantage of the visualization and the experience that you can get from your data and from the agents. Um, but even without that, you will still be able to play well.
It's awesome. Yeah. Let's move on to the first part of our demonstration. I'm gonna do a short demo of the app that we have today. So this is the sentiment chip that some of you might be familiar with. The whole concept of this app is to be able to analyze the sentiment of reviews that customers leave for restaurants. So you're all familiar with TripAdvisor, Google Maps, and whatever other food restaurant applications people use. There are a lot of disgruntled customers, and we're always happy to see um, positive or negative reviews that orient us as well customers where we should go and eat. At least I check every restaurant I go to. So the app that we have today, we allow people to leave reviews, and we will extract the sentiment of these reviews automatically. And there is also a multimodal image extraction case that we're gonna see how that works as well. So let's see how the app works, and then we're gonna dive deeper into the actual implementation. As you can see, this is a list of restaurants. This is an Angular app that is augmented a little bit by this self-guided tour, as you can see. So I'm just gonna walk you through the app. So to get started, we need to go to the first restaurant or any restaurant from the list that we see here, and we will see a restaurant details page. As you can see, it's main details kind of workflow. Many demo applications that I built are, well, we have a list of things and then we have a details page. Super simple. The data that we see here today is actually coming from a MongoDB Atlas database. There is some data coming from the sample data set that we offer in MongoDB Atlas, and this is where we uh, query the data from. So this is actual data from a database. And here is our AI magic feature, just a form that allows you to leave a review. So I'm not going to type everything. I have the self-guided tour do that for me. So the first review we leave is very positive. We have the words incredible. I'm going to zoom in a little bit. Incredible place. I would love to visit again. Blah blah blah. Yeah, you know how it works. We submitted the review, and now we are gonna get it analyzed. So what is the analysis? I'm gonna zoom in a little bit because I'm sure if you're watching on a phone or like a small MacBook or ThinkPad, you're not gonna see what I'm showing. So the first analysis we got is positive. We have a positive sentiment. This is something that, again, the ML model analyzed for us, and we're just showing that in the UI. We also have scores in three different categories: full service and atmosphere. So the scores are from 1 to 5, and the model decided that this deserves the highest scores for every category. Now that's a lot more useful than a text review. We already get some kind of information about the sentiment that people have when they visit this restaurant. Let's try a negative review. So went here for an early dinner, don't drive here, parking is terrible, no liquor license, I guess that's bad. The food was mediocre. So let's click done. These are actual reviews that I copied from TripAdvisor. So we have a negative sentiment, as you can guess, and the category scores are also low. So we have 2 for food, 2 for service, and we have the label not specified for atmosphere. So if the model doesn't have enough information to analyze one of these categories, it's going to return not specified. Or at least that's what we instructed it to do in the prompt. We can't always predict what the GenAI model is going to do. What else do we do here? So let's put in an ambiguous review. So really short on information. We came here for drinks. And as you may guess, we get a neutral sentiment. So we don't know what the sentiment is, and not specified for all 3 categories. Let's try doing this again, but let's put in some images with the same text. So it's going to take a couple of minutes for these images to get uploaded. They will go to Google Cloud Storage, and once they go to Google Cloud Storage, we will send them to a Google Cloud function, and this function will send them to the Gemini multimodal API, which will extract some tags and sentiment from them. Let's zoom in a little bit. So what do we have here? We have an image, a stock image, obviously, of people drinking beer, having fun. So the tags that the model managed to extract are beer, outdoor seating, nightlife, and we get a positive sentiment. Here we have food, friends, restaurants. I would guess these are wines, but we can't really tell. So we didn't get that wine. Maybe we should have. We have bar, beer, again, it managed to recognize the glasses, and friends. And they all have positive sentiment. So let's see how these affect the overall sentiment of the review. So we will get that metadata that we extracted, and we will send that together with the review text to the model to analyze the sentiment. So see what happens. And we got the negative sentiment again. So honestly, depending on the lunar cycle, you're gonna get either neutral or positive. And you can't really predict that because, with generative AI models, you get a lot of creativity. So, you can't always get the same results. But I promise you, if you try this at home, this app is published, so I can share the link in the chat, and you can try this. Let's finish the demo first. You can try this at home. You might get positive sentiment at some point, maybe tomorrow morning. The last 2 things I want to show you are using MongoDB Atlas Search, which is a very capable full text search based on Apache Lucene. So when we search for beer, we will get the review that has the beer photos. And this is because the tags have, beer. We extracted the tags and we're able to search through that metadata without using vector search, without using anything else. And the final AI tree that I built into this demo is generating a summary. So whenever we reach 3 reviews, there is a trigger that executes another Google Cloud function that summarizes all of the reviews. And that's everything in this short, tiny demo. Again, the multimodal use case of Gemini here is extracting sentiment and extracting tags from these images. As you can see here, we have the tags and we have the sentiment. And we are able to search for images without doing any vector search or anything else. We just have tagging. Super simple, pretty old technique, but it's pretty powerful, much cheaper than vector search if you ask me. Vector search is incredible, of course, but if you're looking for a more convenient, cheap solution, well, that might work for you. All right.
Uh,
Yeah,
Mira, are you able to hear me?
yeah, I can hear you. You're good. Yeah,
Oh, cool. I
cool.
had this. I mean, this is a really intriguing demo, and of course, is feeling the same about the discussion that's been going on. I'm curious to know. What is the application? What is the application that's powering it? What is your tech stack? Can you talk a little bit more about what powers this UI, this application?
Of course, yeah. So the UI is built with Angular. Um, I love Angular. It's like so straightforward to use, and I've never bothered with any other frameworks because it has everything built in. All the data is going and coming from MongoDB Atlas, and of course, for analyzing the data, we are using Gemini. So let's switch over to Google Cloud because I've shown this demo before in one of these live streams, and people were really interested in the Google Cloud part. So I want to kind of focus on that today.
Cool.
You see here that this is Google Cloud Functions. It's a bit scaled. Yeah, okay. So this is Google Cloud Functions. I'm going to expand this. And we have this function called Analyze Media. I'm going to show the code in a second, but I just want to highlight that this is the function that we use to extract stuff from the images. And then we also have a second function called Analyze Review Sentiment that analyzes the actual review together with any image tags that we might have um, added. Cool. Let's take a look at the code of these things. So, and call me old-fashioned, but I can't really deal with Google Cloud Console. I prefer looking at code on my local laptop. After I zoom in enough, I'm going to show you the Analyze Media function. It's a JavaScript function. Abby, what languages does Vertex AI support? What languages does Vertex AI has SDKs for? You're muted.
Sorry about that. I was mute. Java, Python, Node, and there are a bunch of other languages, Golang, bunch of other languages that you can find APIs and client libraries for. The documentation is it's pretty detailed, and on top of that, you can directly, if you go to Vertex AI, if you have Vertex AI on your tabs open right now, Mira, if you can just go to that,
Yeah.
or I can show that to, yeah, if you have it, just go to Vertex AI Studio. There's one easy way to get started with programming with large language models, particularly with Gemini or any model from Vertex AI, is that you can get the starter code right from Vertex AI Studio itself without having to, scramble around with the documentation to setting up your own template code and everything without having to do all that. Just go to Google Cloud Console, search for Vertex AI. And once you get the Vertex AI console, just go to Vertex AI Studio from the navigation menu in the left. It's loading. So, yeah. Just go to Overview,
Where is overview?
Vertex AI Studio, right in the, yeah, right below that. Overview. Just go to Multimodal, try Gemini button.
Yep.
Yeah. So just upload a picture and just write a line of any prompt that you want, and hit enter.
What should I write? Sorry, I'm
Just
distracted.
any prompt that you want. If you want, you can just upload an image of one of the restaurant images, and then just say what is the sentiment from the image or something of that sort.
I don't want to upload anything.
Okay,
This
no
guy.
worries. Okay, just write a prompt like why is the sky blue or anything. What's up?
That's okay.
Not much. Cool. Just click the get code button on the top right corner. Yeah.
Okay, and here
Yeah.
we can actually get the
You
code.
have sample code here for Python, Node, Java, and you have sample curl as well if you want to get started with just testing how it responds on the web. But
Nice.
besides that, it also supports other languages. But this is your getting started code. Like this is how you can easily get started um, with generative AI code and then get response immediately. Yeah, that's pretty much it.
Yeah, my laptop is just, it's not the day for
No,
showing.
yeah, I was just wanting to show the starter code right there. That's about it.
Yeah,
Um,
it's
yeah, so that is where we get started. And documentation has more languages than you see in the get starter, in the get code section. So to answer your question, Mira, yeah, it supports all the golden, silver, and other languages too.
sounds good. Yeah,
There we
and
go.
yeah,
You got the response right there.
nice. It did respond. Actually, responds with multiple candidates or multiple answers that you can use. It's really cool.
Yeah.
So to get
So
started with. Yeah.
yeah. So can you show the data structure like from MongoDB? Basically, I just want to see the application that you have built. What is the source data for it? And then after you applied generative AI, of course you updated it, and then you have the data stored back. The processed reviews or the consolidated reviews, you wrote it back to MongoDB. So just as a segue between that to the conversational bot, let's just showcase what the data looks like behind the scenes.
Yeah,
And then
I
I'll
just want to
probably.
know a couple of cloud functions first, and then I'll go over the data. Yeah.
Oh, okay, sounds good. I thought, okay, yeah, perfect.
Yeah. So I just want to show you guys the functions that I use to analyze the images and to analyze the sentiment. So as you can see here, we're using Google Cloud Storage, and you need to add your bucket name here. I hid that just for safety reasons. And here's the actual prompt. Really simple. Analyze the sentiment of the photo. It works with videos as well, which is really cool. Generate the description. Generate 5 tags describing what's in the photo or video. The information will be used for an application for restaurant reviews, and it should be relevant to food, interior, service, and overall sentiment. And here is the fun part. So it always must return a JSON object, and this is the definition of the JSON object. We have only sentiment, description, and tags. And of course, it doesn't always return JSON, so we do some more magic to actually instruct it to do so. So we add the prompt and we add an answer. So this is a few shot prompt. So this should be the answer. So the model should look at this answer and return its own answer in a similar format. Uh, then we actually extract whatever we are sending. So this is the file from the bucket. It's a Google Cloud function, so it can automatically connect to Google Cloud Storage. We don't need to care about authentication. And let's look at the function that calls the model. So
Google
we
Cloud
instance
Storage is where you're storing all the review images.
images. Yeah, the images and videos and stuff. So we get generative model, and this is the model we're using. It's Gemini Pro Vision. Then we add the text that the user, no, sorry, the text is the actual prompt. So we have two parts, the prompt, what we need to extract from the image, and also the file. So this is the file that we are sending for analysis. We get the response, and we send back the first candidate, so the most likely response. And let's see what we do with that. Well, we do some further processing just to make sure we get rid of any tags. So if we get a response that's not looking like this, but it's looking like this is a regex that gets rid of these two tags and leaves just the JSON. And then we try to parse it. There are a few libraries, JavaScript libraries, that can also try and extract and fix JSON errors, and I've tried using these as well with some success. But yeah, they kind of work. So you send by the response, and that's it. That's how you analyze an image. You just say, well, respond to this prompt, and you need to use Gemini Pro Vision. Where is it? Yeah, this is Gemini Pro Vision. There is Gemini 1.5 Pro Vision nowadays. That's released really well a couple of weeks ago, so you can use that as well. And the other function is the analyzing sentiment function. Let's look at this. Here we have a similar prompt, so analyze the sentiment, return invalid review if the review isn't contextually related to the restaurant, has inappropriate language, or is meaningless. We have again some sample prompts, so these are really useful, guys. So if you're struggling with getting the right format for your responses, try sample prompts. And I add the sample prompts, then I add the actual prompt that they need a response for. Again, I try to sanitize the response. Here I'm using a library called djson, also known as dirty JSON. So this is the Node.js package that takes the response and tries to remove any extra symbols that Gemini might have outputted. And that's pretty much it. As you can see here, we are saying generate content stream, same function, but we're not actually using the generative vision model. We are using just the Gemini Pro model this time. But yeah, these are the two functions. If you're looking for the implementation of that, there is also a GitHub repo. I'm going to send that in the chat. So Pedro actually sent in the chat the link to the application, and he will also send you the link to the GitHub. Let's actually this one over here. All right. So we have the repo. You can take a look at it. And finally, I'm going to show you the MongoDB Atlas collection that we are using to store the reviews. Is this the right one? Yeah, sample restaurants. As you can see, we have the data for the restaurants. This is what I mentioned. So we have the name of the restaurant, the neighborhood, the cuisine, and so on. They're all restaurants in New York because that's where the data came from, I guess. Whenever you type a review, it goes into a collection called raw reviews. So we have a lot of test data, as you can see. We have the name, the person who left the review, the text, and the date, and obviously a reference to the restaurant. This isn't automatically displayed in the UI because some people might enter inappropriate language here. So whenever we add a raw review, whenever we insert a document in the raw review collection, there is an Atlas trigger that picks up that review and executes the Google Cloud function. When we execute the Google Cloud function, we analyze the review, the sentiment of the review. Of course, we are going to dismiss any irrelevant reviews or reviews that are containing offensive language. And the process reviews will get stored in the process reviews collection. Now, this is what we display in the user interface. So you can see we have an images array. Sometimes we have images, sometimes not. And we have the actual analysis. So we have sentiment and the scores for food, interior, and so on. Let's look for something that has images. We have one image here, and as you can see, this is just pointing to the name of the image in the Google Cloud Storage bucket, and we have the description and some tags that we extracted. All right, and this is what Abby is going to use. This is the data that she will use to build an AI agent with Gemini.
Cool. Thank you, Mira. Can I share my can I share
Yeah,
my screen now?
go ahead. Yeah. And to answer Naveen's question from the chat while you're sharing, yes, we will have this recorded. You will be able to access the recording in YouTube and LinkedIn after we finish streaming immediately. So it's gonna stay on there until YouTube goes away or until LinkedIn decides to delete all the live stream recordings. The project is publicly accessible, so you can find it in the GitHub repo. And of course in the deployed application. It's deployed on Firebase hosting, so really cheap and efficient way to host your applications if you haven't used that before.
Okay. So I just want to, can you, I just want to confirm before I begin, is my screen shared? Can you see?
Yeah, we can see your screen. Yeah, you can switch over to Google Cloud.
Cool. Thank you. So before we get, so just as an overlap, before we get to the part where we talk about how we're going to consume the data that we just saw and in the application in the front end that and the web application that Mira was showing and how she was able to consolidate the reviews for restaurants based on the images and the sentiments based on the images, so on and so forth. So basically, the review summary and the ratings that are given to restaurants based on the food ambience, interior, and so on and so forth, they are categorized by total score, food, service, interior, sentiments, overall sentiment, and we have some details from the review comments itself, right? So all those are summarized, and this is just a screen snapshot of what the data looks like. I just want you to take a look at what exactly we are dealing with, what kind of data we have. I mean, from fields perspective, and this is what we are going to feed in as. So this is the kind of information we have. Like already we have this processed and we have the analytics data available in MongoDB. Now, if I were to use it directly or use or use an analytics data warehouse or a database per se, and then integrate and bring that data like you would do with a data flow integration and bring your MongoDB data to BigQuery for your analytics purposes in a specific data warehouse, that's another approach. I mean, that's the best practice way to do things because we would want to have our data layer, the transactional or the operational database, separate from the actual analytics warehouse part or the analytics part. And that is where we typically do our embeddings, we do vector search, and you can even do Gemini or Gemini 1.0 Pro, Gemini Vision, or any data structure for that matter, any model that you want, multimodal or language model or text model from within your database and do your analytics over there. So that is always an option. But what we are going to do right now today is, because the focus is on building conversational agent, we want to see how we can leverage Gemini to summarize the information that we already have in this data structure, in the data that in the collection that we already have. So this is the collection we have, and this is the kind of data that we have. Now, is it enough to just go ahead and do this? Yes, Gemini will still be able to understand this JSON as it is and process questions from within the different categories of data that you have right here. But for the sake of implementing it in a summary fashion and to bring in like in a production environment or in a real world environment, to bring in the essence of how you would operationalize this use case, what I've done is I've set up a cloud function, Java cloud function, which reads this endpoint from MongoDB, the data API. So the data API endpoint from MongoDB is going to result in a result set data set like this. Of course, you can filter it based on what you're looking for. Currently, I've just taken all the data that there is. So we have some duplicates in the data. So I have run a few executions, and I have made sure that I have unique results to show as much as I can. But just take a look at let's take a look at what we're going to discuss today. First thing, what we'll do is we'll do a cloud function that will summarize the data that is already here, but it'll summarize it in a way that it concatenates the data along with the description of the restaurant, along with the score for food, the score for service, score for interior, sentiment, and so on and so forth. And on top of that, what else it'll do is that it will take user's search text as the input and match that and bring out the top 5 matches that correspond to what the user is looking for from the description summary that we have concatenated, and then we'll respond. Before going into the cloud functions part, let's just see how Gemini let's just see the result in Vertex AI Studio, because that will give you a good idea of how you typically prototype for applications like this. So let me just quickly open that. So yeah, so this is my prompt. If you look at it, if you can see my screen, I have given the JSON array of a lot of restaurants on the details, like description, ID, images, total score, food, so on and so forth, sentiment score, and the entire data set that we have. Because I'm using Gemini 1.5 Pro Vision. In this case, you don't need Vision, but I'm just using just in case there are some image uploads that I want to do. I could use that, but I've not really used any image in this prompt, but you could. So that's why I didn't use 1.5. I'm sorry, I didn't use 1.5 Pro Vision. I've used 1.5 Flash. Again, depending on your requirement and depending on your token requirement, you can choose the one that fits your needs. I have a pretty lengthy prompt here. Typically, this is not a best practice. You wouldn't have multiple requests going back and forth with the entire prompt string in context. Basically, we have the entire result set from MongoDB, from the endpoint, the entire result set as a part of the prompt. That's not a best practice. Ideally, what we would do is we would create a prompt context where we'll cache the prompt, the entire prompt that needs to be repeated, and we'll only reference the cached prompt, and then we'll only pass in the real time the user prompt to make sure that we are doing the matches based on the context, and we wouldn't be sending the context back and forth to the API, the model endpoint. But in this case, since I'm showing this in a prototype in a Vertex AI Studio environment, I've just pasted the entire prompt right here. So that is why you see a lengthy string here. This is all the data that is coming from MongoDB, right? So I've just taken this here. So let's see what is the rest of my prompt is. So the rest of my prompt is this. Here goes. Here is the search text. I'm looking for creative restaurants that have creative food options, basically, that probably mix multiple food that is there, and or probably mix multiple cuisines, something of that sort, right? Fusion, something of that sort. So as a user, I'm just looking for creative restaurants. And what I'm saying as part of the prompt is return the closest 5 restaurants or closest 5 matches from the JSON array that match the search text, which is the creative restaurant, in the form of a JSON array with your name, description, images, sentiment, and total score values. And this is the response that I get from the model. We have repetition in data, so that's why you see this. Typically, just if you have real world data, you'll probably get the corresponding response. It'll bring out the format that you want. You wanted this in a JSON format, so that's what you're seeing here in response, and you wanted only these 5 fields: the name, text, images, sentiment, and the total score. So that's exactly what we're seeing right here. And all of these match with the search text that I have, which is creative restaurant. Why is it creative? It has creative food in its description. It also says that it has a nice twist of the original recipe. So of course it's creative. So of course it matched with the search results. So this is the Gemini 1.5 Flash 001 model. So if you're wondering so if this is the first time you're attending any generative AI session, or if this is the first time you're hearing generative AI models from Google Cloud, or this is the first time you're viewing Vertex AI, it's a lot of jargon flying around. So let me just explain what this is and explain what each one is, and before jumping into the cloud functions aspect and what exactly we are doing there. So we all know what generative AI is. We saw that in a demo where Meera was just showing how she used generative AI to get the sentiment from an image without using vector search, or without programming, without doing any machine learning with images, and without any description about what exactly needs to be compared, right? So it generates results. You just you, instead of training the machine to do something based on data, you're asking the model to do something based on your request. That's it. Provisionally, you can also have data that you want to tune the model that are already available as foundation models, in which case you're training the model to work for your data that is specific to your business, that's specific to your industry. That is also a possibility. But generative AI, in general, just means that you can ask the machine to do something, just like we asked WhatsApp, or why is the sky blue, or something of that sort, right? So, and what is Vertex AI? Vertex AI is that service in Google Cloud, which is an assortment of all things AI, all things ML, and all things generative AI. You find the models, you find where to do ML pipelines, you do parameter tuning, you do model tuning, you write prompts, you store prompts, you do prompt templates, you do in the entire end-to-end ML pipeline operations, ML pipeline and ML operations, and what we call as generative AI pipeline now. Everything that you want to do in the AI, ML, and generative AI area, you would be able to do from within Vertex AI. That's our one-stop solution for all AI ML needs in the Google Cloud platform. Now, what is Gemini and how is it different from Vertex AI? Vertex AI, like I said, is that one-stop solution where you have all available product services and features, whereas Gemini is a model. We have multiple versions, like you can see right here. You have a list of models. Since I've chosen multimodal model, you're seeing, maybe this is just language model. That's why you're seeing everything. You're seeing Flash, you're seeing Pro 1.5, you have 1.0 Pro, 1.0 Pro, 001, and then there are other Palm models, Text Bison, so on and so forth. And then you have code models. So each model category the models are grouped based on their capacity, based on the purpose, and also features, right? So you have Palm models for some lightweight generative AI solutions. You can still use Text Bison too, but you will get the ideal results. You'll get the best results if you use Gemini 1.0 Pro or 1.5 Pro, depending on what you need. Of course, Flash is also there. That is specifically for super speed and efficiency, and the context window is 1 million. So that is device centric model response. If you want response from models in specific devices with specific capacity, and there is a specific speed and efficiency requirement, that's when you go for Flash. So there are reasons and there are features why you go for one model over the other, but there is a clear distinction between text, multimodal, and code. Text, of course, if it only deals with text, like in the case of the demo that we saw right now in the restaurant sentiment demo, we cannot go for text models, right? The reason is we have images involved. It's not just text. You're not just finding the sentiment based on the review comments. You're also finding the sentiments based on images, right? If you have a picture of a restaurant and just say, describe the ambience to me, you should be able to upload that image, and your model should be capable of dealing with the multimodal nature of your input. So that's why we have the vision models as opposed to the plain text models. And then we have code models, which help you generate code for your requests. So let's say I want to generate cloud functions from it and I don't have a starting point. I can ask Gemini to help with it. But of course, we have other code assistants like Gemini Code Assist within the Google Cloud Console platform, like you see right here, and also within Cloud Shell platform, which you'll see if you open Cloud Shell editor. Right in the left, you will have Gemini Code Assist. So those are more curated for code assistants. So you will use those directly rather than going to a model and programming. I wouldn't. Maybe there are some use cases where you would want to use the code models. For example, you're building an examination platform where you're expecting the students to submit code and you want to validate, you want to generate test cases for it, so on and so forth. You could use the code. You could use the code models to program that. But technically, if you're using it as a productivity tool, you can use it from your Cloud Shell. Cloud Shell terminal or Cloud Shell editor or your Visual Code editor, wherever you're writing and editing code, you could use that code assist feature. Anyway, so this is just where I wanted to showcase what a response a prompt is going to be and what the response is. So this is all I want to do with the cloud functions. If you ask, is it not there already in MongoDB? This data is already there. Yes, but here, if you like from your, we are separating the analytics part from the operations part of it. So we want to keep cloud functions to exclusively do the summary and do the similarity matching. If you notice, I'm picking top 5 matches. Now, is this the ideal way to do it? You can leverage Gemini to do these matches on a generic sense. But if you're looking for more specific responses, let's say you're a retail company, or you're actually a restaurant business and you're looking for restaurant consolidate or aggregation business, and you're looking to get specific results and you want to be extra careful, there you could use Gemini always as a fallback, and you could use vector search from more like using the embeddings API, embeddings model, and in along with the vector search like cosine similarity or Euclidean distance or something like that within your analytics database. In this case, let's talk about BigQuery for that matter, right? Within BigQuery, you're able to consume the data as it is. You're able to convert that into embeddings, and then you're able to perform vector search. Why is that important? Because that will give you more specific results as to what are the nearest neighbors when I compare that with the user's search text. So without relying on just what generative AI thinks is your response is related to the JSON, which is still possible. It is still capable of sorting to sifting through all of your JSON list of elements and then comparing it with search text. But ideally, for a production solution, you would want to have deterministic results, and that's where vector search will come in really handy, because you will be able to measure exactly what the distance is from the search text. You will be able to prioritize one over the other, and so on and so forth. And you could use Gemini as a fallback option, where you would say, okay, now, so this is how your distance functions work, right? You use let's say cosine similarity. It will say how close your search result, your similarity, your nearest neighbor is from the search text. For example, in this case, I'm searching for creative restaurants, but I also have responses that have come up that says the food was mediocre. In case ideally it wouldn't, because in this case we have not got that result. But instead of creative restaurant, let's say you had some other search text, and you had specified that this restaurant should not serve any meat, or it should not serve mushroom, for example, or it should not serve peanuts, something of that sort. You have such kind of a specification. Vector search will be able to find the nearest neighbors based on the words, or based on the elements of your the constructs of your search text against what is there in the database. Like in this case, we have all these JSON structure or all these details. But let's say it identifies something that has peanuts or without does not have peanut. You don't know whether it has understood the meaning the way generative AI will. So that is why we'll use Gemini as a fallback option in that case. So this is just one design pattern, like I would think so, where you use the results from your operational database. You would convert that into embeddings. You would do the vector search, either a cosine similarity based vector search or a Euclidean distance, or whatever what distance works for you. You identify the responses, and then use Gemini to score whether or not the matches are really valid matches. For example, like I said, I want restaurants that have creative dishes, creative food options, but I don't want the ones that serve peanuts. Now, if even if the vector search has resulted in similarity, because you're not filtering by any percentage of similarity, right? You're just saying give me 25 nearest neighbors. Now the 25 nearest neighbors that you've caught from your vector search may or may not include the peanut, because it is still it's still, it has some distance, but you have not filtered by distance, so it will have restaurants that include peanuts for that matter. Now, what you'll do with Gemini is you can probably set in a prompt that says, this is my user search text, and these are all the responses from my vector search result, my nearest neighbors. Now, validate the score, or validate how close or how far the response is, and tell me whether or not it really makes sense. Because the user says no peanuts, but if the vector search thinks, hey, I found peanuts, so it's it's really a nearest neighbor, Now compare that result and say whether or not it's a thumbs up or thumbs down. If it's a thumbs down, I'm not going to send this as a chat response to my user. Now, why am I talking about chat response? Because ultimately we're losing sight of that here, because I know I'm taking a lot of time talking about vector search and databases here, but just because it's interesting. But the whole point is we'll be building a chatbot or conversational experience in a little bit, and your conversational experience should respond with the relevant responses to user. It cannot say, when the user says no peanuts, the no dishes with peanuts, this restaurant should not serve any dish with peanut, and then your vector search results comes up with there you go, this is great, it has great ambience, it has creative fusion cuisine, but it serves peanut. But that's not what you want. So that's exactly what Gemini or any model, one of these models that you have right here, will do for you. Is it will understand the language rather than just doing an indexing based or a meaning or context based similarity search. Now, is context based similarity search bad? Not at all. Definitely it is good. You cannot, the best practice is not just to use Gemini as a pattern match or a vector search result. Of course, you could use it, but the best practice is always to use it in association with vector search results, because it understands the user's needs. But you also want to be deterministic in your results for your standard production solution. So it is always good to have a solution, a database solution. When I say database, it's data warehouse solution that also, in addition to taking the response from your operational database, it is also able to give you the in place embeddings and in place vector search capability, which all the Google Cloud Analytics databases give you that ability today. So you should be able to do that, which means you will be able to use SQL queries and just do the vector search with just a cosine similarity clause, and you should be able to get the results. That's not in scope for us today. I'm just highlighting that as a standard best practice to get your make sure your production applications are in fact returning deterministic results because of the nature of generative AI responses in general. Now, in association with the fallback option, which I'm talking about, where you're asking generative AI to validate whether the returned similarity is in fact a response that you can return to the user, then yes, out of the 25, we only want the top 5. So here we are going to assume that we've got already the similarity from vector search, even though we are skipping that step for now. But let's say all of these are similarities results, and I'm just using Gemini here to compare to confirm whether the similarity is in fact relevant to the user's search text or not. So that is what we're doing right here, and this is the summary. um, like I said before, you can click get code, and you can generate, if you're a Python developer, and there are other supporting languages as well, which you can look from the documentation. There's Golang and other things, but this is where you can find your startup code. You can copy this, or there's other ways to do it. Go to Google Cloud Console. This is, if right next to the search bar you see the Gemini chat icon, and right next to that you have open Cloud Shell or Cloud Shell terminal button right there. Just click that, it'll open this terminal. You can toggle between, so every time you activate Cloud Shell machine in Google Cloud, it gives you two things. One is a machine with where you can write code. It's very similar to your editor, like VS Code editor and other code editors. It allows you to integrate your code with a version control, GitHub repository, and all that. It allows you to save projects. It allows you to build product projects, and so on and so forth. And it gives you a terminal, which you're seeing right now, which allows you to interact. It's like you are interacting with all of Google Cloud services through the command prompt using gcloud command. So those are the two things. And once you open the editor, let me show that. I have it open right here. Here we go. Where was it? I thought I just had it. Okay. Once you open the editor, as you can see right here, it has all my projects that I have active in my active Google Cloud project account right now. And I'm able to write code here, and I'm able to interact or execute or do whatever I want, deploy, or anything that I want to interact, all kind of interactions that I want to do with Google Cloud Console. If I don't want to use the console and I want to do it using commands, Linux commands, I would, or any gcloud commands, you could do that from your terminal. So that's what Cloud Shell terminal does. Now, anyway, going back to setting up your startup code or your template code, one other way of doing that is you could actually sign in from here. You could click that, and by clicking this, it'll open up an option, a list of options like we see right here. You go to new application, and then you choose what you want to do, whether it's Cloud Run or Cloud Functions. Let's say I want to do a Cloud Functions. You choose Java or Python or anything of your choice, and then give a name. And once you hit enter, it automatically creates the. Right now, I'm not doing that, but it automatically creates a project of the chosen framework, and it generates a template code for you, whether it's Cloud Run or Cloud Functions. It does all the boilerplate work for you, so you don't have to write your Docker file. You don't have to do this and that in order to be uh, in order to get going with your application code itself. So that's one thing that I wanted to just plug in there, so in case you're using Google Cloud Console for building applications, or what you just saw in Mira's demo to draft the cloud functions. All right. So in our case, we already discussed that we have a cloud function. So this is the cloud function. I'm just going to walk you through what this actually does. Um, so basically, I'm reading the endpoint. I have everything just in my code right now. So this was just for the demo. So yeah, it's a simple cloud function. So what it does is it basically calls the Gemini 1.5 Pro Vision, and I have set up my safety settings. It's set up at a very high level. So basically, a lot of responses get blocked. But that's okay. You can always change this to you can keep the safety setting to a low or bare minimum, so that most of your responses are not blocked. You can also change your safety setting and customize it, and add keywords that you don't want to see in your responses, or don't want to occur in any of the conversations. So that you can set as well. So here is my prompt, the prompt that I showed you in the prototype, in the prompt Vertex AI Studio. So the same prompt is right here. What I've done is I have not invoked the entire sorry, I've not included the entire JSON from MongoDB here. Instead, I'm using MongoDB's data API to get the results from MongoDB directly. And I'm appending that with my prompt. And I'm also including the user's search text in my prompt in order to get the response. So yeah, so that is the top 5 restaurants results. And what else is here that I wanted to talk about? Yeah, the Gemini call is something that we saw. And then, there are 2 calls that are happening here. One to the source of the data from the operational data store, which is MongoDB. And then the call to generative AI, which is the Gemini call, where assuming that you already did the vector search and you got the similarity matching, in this, you don't have to do it. You can still continue to use Gemini directly, but that's in order to get deterministic results is the ideal way. Get the vector search results, the similarity results, and then use it with Gemini call as a fallback to catch whether or not the response to the user is in fact a relevant response. Now we have the data store ready. Let's see how to build an agent builder experience. I want to pause here and just see if there is any thing that I'm overlooking in terms of questions. Uh, are we good, Mira? Is there anything that you want to call out that I missed in the chat?
No, it's all good. There is a question from Takunda asking, can we say that embeddings is the same as RAG, as in, yeah, retrieval augmented generation? Do you want to take that one?
Sure. So embeddings is just a numerical or a vector representation of your data, which is an array of floats, if we have to simplify it. Why do we have embeddings? It's just to make sure your indexing and your search results are happening faster. Your search is faster. And also, it's a way to represent your data, that you're able to search data structures of different formats, and you're able to find similarity without going to, like, typically if you would do it in the traditional ML way, or the traditional AI way, or in the pre-embeddings era, the way you would do it is probably just train each and every image based on the elements in the image, and train each and every part of it, and then identify your image to see whether or not it matches. But that was never a thing. We have had embeddings for several years now. It's not new. It did not just appear all of a sudden, just along with generative AI. It has always been there. It's just that we did not recognize it as generative AI in the past. Embeddings have always been there, just like your search results or YouTube search results. stuff like that have always operated on embeddings. So that's what embeddings is. Embeddings is nothing but a mathematical representation of your data, any data, text, image, video, whatever it is. Is it same as RAG? No, RAG is retrieval augmented generation. It's a concept where you add context to your data, and you search based on that context in addition to other generative insights that you may derive. So RAG is a concept. You can design your RAG based on incoming real-time information, context information that is coming, say, from a PDF. Or so in this case, we are building restaurant business, right? Like restaurant review summary. So let's say you have embeddings for all your data, all your images, or all the review comments, and then you're trying to match that with the user search. But your context could be the description of the restaurant's original menu, or the restaurant's original documentation of what they serve, what their food contains. So that could be the master uh, superset of data that has everything about that particular restaurant, right? So that is a source. It could be a PDF, it could be a data set, it could be a CSV, anything of that sort. That's RAG. How you interact with your RAG? Sometimes you use vector search, sometimes you do data chunking if it's in PDF. You do a lot of things, but it's up to you to design your RAG architecture. But I hope that helps, Takunda.
Yeah, yeah. I think you made it clear what's the difference between the two. Pedro, can you quickly
Okay,
share my screen just so we can share this link over here? So if you want to sign
sure.
up for MongoDB Atlas, there is a free way to do it. Um, you can follow the link over here, mdb.links/smart-dining, which is the name of our live stream today. So yeah, you can create a free account. You can create a free vector search index as well, up to 3 free indexes, and try out the vector search functionality. You can also try and run the application that we shared earlier, and connect that to your free MongoDB Atlas cluster. Um, yeah, and Abby, do you have any follow ups that you want to share with our audience today?
Yes. Do we have to do that now? I mean, how much time do we have? Are we at time?
I think we're pretty much done.
Just the agent. Okay, I thought it was till 12. Sorry about that. I mean, it was for another half an hour, so we haven't started the agent builder. Do we have some time, or we're done?
We can do it for as long as we want, I guess. As long as folks are here. Again, the
So here are
recording.
three links.
Yeah, go ahead.
Okay, I have a few links. Let me give it to you in private chat if you can put that in the chat. That's also helpful. So one is for signing up for innovators. So this will help with all of everything that's new with Google Cloud. And when you sign up with innovators, you get Quick Labs credits, Google Cloud credits. I think apart from the $300, you would get some more Quick Labs credits as well. And also you'll get notified for everything that's new with respect to features or any events that are happening around Google Cloud. So you'll get notified of all that. So that's one thing for sign. I think the links are stuck with each other. Let me just send it again. For some reason, it's doing the same thing again. Let me send it one by one. Yeah, so that's the innovators link, and the medium link is there are two blogs. Part one is important for us to set up the backend data. The steps that we discussed are pretty much the same. The cloud functions creation steps are same, except for that that's a different use case in the blog, but pretty much similar, very similar steps. And the second part of the blog is talking about how to set up the agent builder, which we'll see now. If we have like 5-10 minutes, I can quickly show that. So those are the two things, the three links that I want to share with the audience today. Yeah, remember to sign up for innovators so that you continue to get notified of everything that's new with Google Cloud, and you'll also get credits from Quick
Yeah,
Labs.
yeah, go
All
ahead
right,
and yeah, you can share that.
cool.
And while we're waiting for that, the recording of the session will be available after we're done. So if you do need to drop off, you can always watch the recording on either YouTube or LinkedIn.
Okay.
And I share the
So,
screen. Okay,
sorry, what did you say, Mira?
that's all right. Go ahead. You can share your screen.
Cool. Okay. So Agent Builder is part of Vertex AI as well. Like I said, all things generative AI, all things AI that are under the Google Cloud umbrella. All AI, ML, generative AI models and features are available as part of Vertex AI. You also have something called as Agent Builder. This lets you build agents low code. At the same time, it allows you to integrate that with multiple sources, like be it PDFs, be it data stores, cloud storage, databases, BigQuery. You have direct integrations to BigQuery. Or if you want to just, let's say, I have my MongoDB data store, I have my agent builder. I just want to plug in the MongoDB results directly. I don't want to do anything. Even then, even that is possible. You'll just use data API, the MongoDB's data API directly as in an open API YAML format or JSON format, open API spec. You just plug that in as a source, and then you can set up an agent builder really quickly. Let's see how to do that today. So this is your Google Cloud Console. Once again, search for you can either search for Vertex AI or just search for Agent Builder directly. It'll ask you to enable the API if it's the first time you're doing Agent Builder. So go ahead and do that if that's what it's asking you to do. So this is the one that I've clicked, and that's what this page is. So what we want to do is create app. So go ahead and click create app. So once you click create app, you should be able to see the four options that are available as part of Agent Builder apps. You have the search app, you have chat app, and there is one more, which is recommendations app. So search is just like your search engine. You're building a search engine. You're not building a chat experience, rather you're building a search engine. So this is one kind of app. There is a chat app as well. It basically operates with the chat models. And then you have of course you have the option to choose your model from the list of options, but that's out of the box chat agent. And then you have recommendations, which will let you create a recommendation engine. And then you have the agent model. So this is in public preview right now. You we can still see, we will still be able to access it. You'll still be able to build it with your personal Gmail accounts as well. um, so if you sign up for innovators, you should be able to do it through quick labs experiences. Um, so this is the one that we are going to choose right now, because we are building an agent, conversational agent with agent builder. So go ahead and click select, and then provide a name to your agent. Let's say I just want to build a restaurant some review summary agent. I'll leave it at US Central 1. Click create. In about a few seconds, you would be able to see the agent console. Just a second, my screen's froze. Okay. Right. So I want my agent to be the restaurant summary or reviews, just reviews agent. And then put in a goal of your choice. So in this case, my goal is going to be this: you're an intelligent restaurant review summarizer. You have samples, you have references for how specific your goal needs to be. So I'm just going to go through this rather than doing this, because I know we are at time. Sorry, I planned for another 30 minutes, but that's why the delay. So let's get going with the placeholders that I already have. So this is the goal that we want to set. So I've mentioned that this particular agent, as I'm mentioning this as the goal for this agent. I'm saying that you have information about restaurants in the form of name, description, images, score for each one, and then your job is to pick the matched restaurants corresponding to the user search text and chat with them about their choice. So that's the goal. Typically, you can be a little bit more specific. You don't chat with them about their choice. You help them make the right decision, and then you help them make the booking as well. So that is the ideal use of an agent, not just chat. So let's say I've picked this restaurant ABC or Clementine, and now the goal is to confirm your booking. Right. So if you have an endpoint for that, you would go ahead and do that. I'm not doing that today, but I'm just saying you would be able to add that as a goal. Instructions. So this is one other important thing. The structure of this, just like your Python code, the indentation and everything is also important here. So you can always look at samples, but the instructions will tell you how to build this agent or how the agent should respond to the user. So basically, I'm instructing the agent to greet the user and answer their question to the best of its knowledge, summarize the user's request, and ask them to confirm that you understood correctly. So basically, when you're summarizing, before summarizing, ask clarification questions like what kind of categories you want. Like, do you want quality? Or if they have not mentioned any cuisine, ask them about cuisine, something like that. Whatever you want your agent to ask or clarify, you can mention that in the instructions here. If not, ask seek clarifying details, and then you can just ask the agent to summarize the understanding and then request, if it's not entirely clear, request for more information. And then what you see right here is a placeholder. So this variable is a tool variable. So the tool is basically what allows you to interact with the, remember the cloud function that I walked you through in the first half of my demo right here. So the cloud function is our source or data store right here in this demo. It could be anything, but I use the cloud function as cloud function in an open API format. I'll show you what the other formats are. You will just see that in a bit. So that's what we reference here. So you mentioned that, but at this point, you would not know, you would not have this in place. So you'll probably not have this placeholder. You'll delete this. You will not have this at the time of creation. You will come back and fill this in later, right? But just know this is the format, and the indentation, the indents are all important because that will navigate, that will tell the flow of conversation to your chat, to your agent builder. Now, available tools. At this point, we have not created any available tools. You can actually click create data store and then continue to manage all the available data stores that are there. We're not going to look at all the data stores today. Rather, I'll show you in tools directly what are some of the tools that you can look at. So here we have tools. I have a tool that is already created, but you have the option to create tool, and you provide a tool name. You provide the type as open API. There are other options. Your tool can be from a data store. It can be a function. You can actually directly reference a function from here, but that's not what I'm choosing. I'm choosing open API because my data set can directly come from MongoDB. It doesn't have to come from a function all the time, even though in this case my source is a cloud function, because I just wanted to summarize and choose the top 5 matches. I want to do some more things on top of the data that is already there in MongoDB, right? So I'm choosing open API instead of choosing the functions option. And then description, I'll show you what that is. Yeah, so data store is like if you want to connect to BigQuery directly, if you want to connect to PDFs, if you want to connect to CSVs. There are multiple data store options. Go check it out when you get a chance to get hands on with it. But for now, I'm going to show the restaurant tool that I've already created. This description is important because everything that you mention, every field that every word description that you provide as part of Agent Builder is an input for the agent to understand the context of your application itself. So give the description of the tool, what exactly the tool does. And I've described this as a backend data set or context information for the restaurant review data. And that it is a match summary for my user's search. So that's what I've described there. Schema. So this is what I was talking about. So my cloud function that I showed you is has a REST endpoint. So that REST endpoint's open API spec is what you're seeing right here. Of course, URL is important. Of course, the request body, response structure, everything is important. It's a typical YAML format. It can also be in JSON format. If you don't know how to generate your open API, you can always look at the sample and craft yours, or there are tools that help you generate this. But you always have Gemini Code Assist. Just ask Gemini Code Assist to generate this open API spec. Give some examples from the sample and say it should be able to respond with this sample right here. It should comply with the structure of the sample right here. So you can always give one shot or few short examples to your prompt in Code Assist and ask you to generate ask it to generate the open API spec for you, which is what I've done. I didn't type this all. I just just asked Gemini Code Assist to generate this, and I got my OpenAPI spec, and that's it. You don't change if for your you don't have to change any authentication type unless you have a specific requirement of an API key or a service agent token. In this case, I have not. I've kept this as a this is a prototype. So I have this endpoint open. So I didn't specify anything, even though this is a service agent. So my service account has access to it. So it's able to access this endpoint directly from the agent. So that's it. Just save your tool, and you have the prototype, the preview of your agent on the right hand side. So this is how my search went. I just said hi, and the search agent said, "Hi there, how can I help you?" I said, "I'm looking for restaurants with creative food options," and then it said, "Okay, I can help you with that. What type of cuisine are you interested in?" And I think since this is a JSON response, it just came up with a list of all the responses that are all the restaurant options that are already there. That's what you're seeing right here. So there are 5 matches which have great like creativity in their food options. Even though this is test data and you have repeated information, but in real world, if you have real information, you would be able to see that difference and you would be able to see the response. Now, there are more advanced ways of processing your results. So that's exactly what I want to show you. As you can see right here, this is for another retail agent which I was building earlier, right before this restaurant use case. So I want to visualize. I want the user to be able to visualize the chat responses. I just don't want the user to see that as a JSON response. So how would you do that? So what you would do is you would create few short examples, right? Because this is ultimately, end of the day, agent builder is also does also a generative AI agent behind the scenes. It is able to take your data set as context, but it understands the format or the request that you have behind the scenes. So you can actually tell that you want the responses to comply with the examples that you have. So create an example. Like in this case, what I've done is I've created multiple examples. I've said this is what I want the response to look like, and if you that I have which will have examples of multiple, like how many images you want to show, and how you want the tiles to be, whether you want in a carousel or a table format, or you want in a list format, or you just want a test description. Whatever you want, you can write your HTML by saving multiple examples, and then you can just expose this agent retail as a with a REST endpoint, and that makes an entry into the next option, where you don't want to use the chat experience of agent builder. You want to just use the agent builder for the conversation experience, but not the user interface. So let's say you are a great front end developer, or you are a great web application developer, and you have like the one that Mira had. If Mira wants to plug in this conversational bot into the application that was demoed before, of course the look and feel and experience should be the same, right? The user experience of the chat assistant itself should be the same. So what Mira can do is just write the chat interface within the scope of the application itself, but behind the scenes call the REST endpoint of this agent builder API, which will use the session ID as an interactive conversation. So it will persist the conversation back and forth with a customer within that session ID, and that session ID will serve as the holding point of your entire conversation itself. So that will drive your conversation using API endpoints. So I just want to stop it right here, because I know we're way ahead of time. Sorry, way over time. And I just want to see if there are any questions or if there's anything that I'm missing right here.
No worries. Yeah, there's still people
Was there
watching
a
on live
disconnect in
and
between?
everything. Maybe. Yeah.
Was that Mira?
I think we lost Abby for a second here. Um,
Can you hear me?
okay. Yeah. Yeah, we can hear there is some delay, but I think we had a pretty good live stream. There is still people watching on LinkedIn. and you can find all the links that Abby and I shared in the chat. If you're interested in learning more, you can always connect with us on LinkedIn. I'm going to send my name over here, my full name, so you can find me. And you can obviously see Abby's name on the screen as well. I send that only to YouTube. Anyway, with all that, I thank you all for joining today, and thank you, Abby, for making this possible as well. It was a really cool and comprehensive demo, um, and I'm sure that it was useful for everyone watching here, and there will be more people watching it on the recording. With that said, you can always tune in for MongoDB TV. Every week we have live streams at the same time, and we have many other shows that you can tune in for as well. And thank you everyone for joining. Have a good night, good rest of your day, or good morning if you're joining from Australia, I guess. Thanks everyone, and bye.
Thanks, everyone. Really appreciate it. Thanks, Mira. Bye.
Thank you.